Review of facial expression detection using deep learning. Abstract. In the past few years, deep artificial neural networks have received the greatest attention in computer science. Pattern recognition, machine vision, and machine learning are some of them. One of its outstanding applications is through facial expression recognition expression area. Facial expression analysis is useful for many tasks, and the application of deep learning in this field is also very important for fast development. Facial expression detection, which is part of the facial recognition, is becoming more and more important and needed because it has greatly increased. Although there is a way to use machine learning and manual recognition of expressions intelligence technology, this paper tries to point out deep learning and image classification methods to recognize expressions and categorize expressions based on images. Index terms: facial expression recognition, deep learning, CNN architecture, emotion classification. Introduction. Facial expressions are essential to human social communication, as this communication is both verbal and nonverbal. Facial expressions are one aspect of nonverbal communication, as the face expresses prominent signals of communication, which includes eye contact. Other aspects of nonverbal communication are gestures and body language. It is easy for humans to notice and understand faces and facial expressions. However, it still proves difficult to develop an automated system that accomplishes the same understanding. There are several problems related to this issue, such as the detection of an image segment as an actual face, due to occlusions or illumination, as well as variations in head poses, extraction of facial expression information, facial landmark detection, or classification of expression. Facial expression recognition, FER, is an active research area in the field of artificial intelligence and applied in vast domains, such as security, monitoring, and law enforcement, marketing and entertainment, e-learning and medicine, emotionally intelligent robotic interfaces, or social humanoid robots. Various fields, like data analytics, psychological research, social gaming, and others that include human-computer interactions, can benefit from the ability to recognize facial expressions automatically. It is said that the emotional expression through face can convey 55% of information. It has been determined that certain facial expressions have universal meaning. By 1978, Ekman and Friesen had finalized and developed the Facial Action Coding System, FACS, and the authors found that there are 6 facial expressions, including happiness, sadness, surprise, fear, anger, and disgust, that appear to be universal across all culture. However, it is challenging for computers to recognize these common human expressions in natural conditions because of differences in lighting various head poses. Deep learning is an artificial intelligence, AI, function that imitates the workings of the human brain in processing data and creating patterns for use in decision-making. Deep learning is a subset of machine learning in artificial intelligence that has networks capable of learning unsupervised from data that is unstructured or unlabeled. Also known as deep neural learning or deep neural network. We have read few articles and papers on facial expression recognition using deep learning and understood different deep learning techniques. Of these different techniques, CNN algorithm will be best suited for the proposed system. To discussion different types of deep learning algorithms are available for facial expression detection, such as deep belief network, DBN, and convolutional neural network, CNN. Of these, the steps that have taken by 7 papers that used convolutional neural network, CNN, for facial expression detection have been discussed here. The main objective of one is to identify 6 basic facial expressions such as happy, sad, fear, anger, surprise and disgust. It has used JAF dataset for training and testing. Convolutional neural network is used for extracting features of eyebrow, eye, mouth, cheeks, and nose, and also for classification. The layers used are 2 convolutional layers, 2 pooling layers and 2 fully connected layers. ReLU activation function is used in all layers. In 2, it classifies facial expressions into 7 expressions like angry, disgust, fear, happy, sad, surprise and neutral. FER 2013 dataset is used for training and testing. 3 models are used, which are a baseline model, a ResNet 50 model and a 5-layer model. Of these, highest accuracy is obtained for ResNet 50 model and 5-layer model. 5-layer model consists of 4 stages of convolutional layer together with max pooling layer, 1 fully connected layer and a softmax layer. ResNet 50 consists of 50 layers. From that, output layer is replaced with 2 fully connected layers and a softmax layer. To get the final emotion detection network called EdNet, 5-layer model and ResNet 50 model are ensembled. ReLU activation function is used in all layers. In 3, it mainly consists of 2 steps. In first step, the CNN architecture is fine-tuned by VGG model to get the first model. In second step, in order to improve classification, the CNN architecture is fine-tuned by first model and final model is obtained. It uses a combination of CK+, RAFD, MUG and KDEF datasets. The main objectives of this model is to improve the accuracy in classifying emotions and to classify the facial expressions to angry, happy, fear, neutral, sad and surprise using CNN architecture. It uses 4 convolutional layers, 3 max pooling layers, 2 fully connected layers and a softmax layer for classification of facial images, and the regularization technique used is dropout. The main objectives of 4 are to avoid the explicit feature extraction process and to classify facial expressions to worried, angry, disgust, surprise, anxious, happy, sad, neutral emotions. The dataset used is Chinese Linguistic Data Consortium, CLDC, which consists of multimodal emotional audio and video data. In order to avoid the complexity of explicit feature extraction process, the faster RCNN is proposed for facial expression recognition here. The facial expression image is normalized and the features are extracted by using convolution kernel. And max pooling is used for reducing dimensions of the features extracted. The region proposal networks, RPNs, are used for predicting accurate region proposals. The proposed method uses only one convolutional neural network, CNN, for all purposes. The softmax layer is used for classification of facial expression images and regressor layer is used for obtaining bounding box coordinates. The main objective of 5 is to classify facial expression into 7 facial expressions like angry, disgust, fear, happy, sad, surprise and neutral. FER 2013 dataset is used for training and testing. It uses 6 convolutional layers, 3 max pooling layers, 1 fully connected layer, 1 dense layer and a softmax layer for classification. ReLU activation function is used in all layers and the regularization technique used is dropout. In 6, it classifies facial expressions into happiness, surprise, sadness, anger, fear, disgust and neutral. Pre-processing is performed using normalization and augmentation. Features are extracted using trainable convolutional layers. It uses 3 convolutional layers, 2 max pooling layers, 1 fully connected layer and a softmax layer. ReLU activation function is used in all layers and dropout regularization is used to prevent overfitting. In 7, it classifies facial expressions into anger, disgust, fear, happy, sad and surprise. It uses 4 CNN networks. First 3 CNN networks are used to segment facial components like eyebrow, eye, and mouth respectively. The 4th CNN network is used for recognition of facial expressions. After post-processing, for each face, a final iconized image is obtained combining the segmented image. The 4th CNN classifies facial expressions combining raw facial image and iconized facial image. 3. Conclusion. In this paper, we have discussed the deep learning AP approaches for facial expression recognition of 6 different papers. All papers are using convolutional neural network, CNN, for feature extraction. Of these, highest accuracy obtained is 99.33% and lowest accuracy obtained is 61%. Since people come from different races, skin tones, skin textures, they may have different facial expressions, it is too difficult to eliminate all these differences. We sincerely hope that further research in this field may solve these problems and provide us with robust, easy to use, and widely applicable facial expressions recognition system.